In this video, I will provide a worked example for a single flow with AIMD congestion control. Alice is streaming a high-definition video at 10 megabits per second from a remote server in San Francisco. All packets are 250 bytes long. She measures the ping time to the server, and the minimum time she measures is 5 milliseconds. Once the AIMD window reaches steady state, for the rest of the video the sawtooth oscillates between constant minimum and maximum values. The buffer is perfectly sized so that it is just big enough to never go empty. Part 1. What is the smallest value of the AIMD window in bytes? Well, the minimum ping time of 5 milliseconds is when the buffer is empty, but the bottleneck link is full. At 10 megabits per second, there's therefore 50,000 bits in the pipe. This means the minimum or trough of the AIMD sawtooth is 50,000 bits, or 6250 bytes. So therefore the answer is 6,250 bytes. Part 2. What is the largest value of the AIMD window in bytes? When the buffer and bottleneck link are both full, the RTT is doubled from 5 milliseconds to 10 milliseconds. At 10 megabits per second, this corresponds to 100,000 bits. 50,000 bits are in flight, and 50,000 bits are in the buffer. Therefore, the maximum or peak of the AIMD sawtooth is 100,000 bits, or 12,500 bytes. Part 3. How big is the packet buffer in the router in bytes? Well, we already decided in question 2 that when it's full, the buffer holds one minimum RTT, or 50,000 bits. Part 4. After a packet is dropped, how long does it take for the window to reach its maximum value again? Packets are 2,000 bits long, and so the window will increase by 2,000 bits every RTT. Therefore, it takes 25 RTTs to increase the RTT by 50,000 bits and fill the buffer. The average RTT is 7.5 milliseconds, therefore it will take 187.5 milliseconds. Part 5. If Alice now tries to watch the same video from a server in Australia with RTT 250 milliseconds, how big should the router buffer be in bytes if the network still runs at 10 megabits per second? Well, the minimum RTT is 250 milliseconds, so the buffer needs to be at least 250 milliseconds times 10 megabits per second equals 2.5 times 10 to the 6 bits. Because we express storage in powers of 2, the answer is 2.4 megabits, or 298 kilobytes. Part 6. When the server is in Australia, after a packet is dropped, how long does it take for the window to reach its maximum value again, in seconds? As before, the window increases by 2,000 bits every round. To fill the buffer will take 2.5 times 10 to the 6 divided by 2 times 10 to the 3 equals 1,250 rounds. The average RTT is 375 milliseconds, so the time to reach the maximum again is 468.75 seconds, or almost 8 minutes. The answer might surprise you. It takes a long time for the AIMD flow to recover from a single packet drop. This would be a real problem in practice, which motivates us to look for better and quicker ways for TCP to recover from dropped packets.